Okay. Today we'll cover the rest of the thread topics, the problems that arise, and the solutions that we can use to actually find this. Um, Yesterday we have seen a problem called as synchronization, and synchronization can be solved by using the locking mechanism. Like whatever that we are trying to use, our thread should lock, and once our thread has done with whatever job it has to do, our thread should release the lock on that particular object so that other threads can make use of that particular object so that there won't be any overlaps in terms of the object being used. Okay. So that locking mechanism actually gives rise to a different set of problem. Okay. Imagine a scenario where there are two files, file 1 and file 2, and there are threads, thread A and thread B. Okay. So there is thread A and thread B, and also there are files file 1 and file 2. Okay, so now what thread A has to do is it has to read whatever is there in file 2 and write it to file 1. Okay, and thread B has to read whatever is there in file 1 and has to read it to the file 2. Oh, sorry, write it to the file 2. Okay, now imagine we have this situation. Okay, so because these are sharing, we may think, okay, our thread A can lock file 1 and read the content from the file, and again our thread A can lock file 2 and write the content to the file. Okay, imagine our thread B also is operating simultaneously. Okay, so simultaneously it is doing so because thread B has to read from file 2 and write it to file 1. What it does, it actually locks file 2. Okay, now let's see the operation sequence that may be happening. Okay, let's say thread A has locked file 1. Okay, so thread A has locked file 1, and now while it is reading file 1, thread B locks file 2. Okay, let's assume that's the case that happened. Okay, now what happens? Thread A, once it has read the content from file 1, thread A has to write into file 2. So now what it does, thread A tries to acquire lock on file 2, but because it is already locked by B, it will not be able to acquire. Okay, so it will be waiting for this file to be released. But what's happening with thread B? Because it has already read with contents in file 2, it will be waiting for file 1. So, but file 1 is already locked with thread A. So what happens is they will never be able to acquire locks on the required files, and that's it. This situation is called as deadlock. Okay, so deadlock is something that is caused by the process of locking. Okay, especially locking in some specific order that we are not supposed to do. Okay, so so that problem is called as a deadlock. Okay, so solving race condition is the if we don't solve the race condition properly or with proper care, we may run into deadlocks. Okay, so imagine all these scenarios. Okay, all these scenarios are deadlocks only. Okay, in the top left corner, so all the cars, okay, no car can move. Okay, because every car is locked by other cars. And the bottom left picture is actually the example that I've just explained. Thread A, sorry, thread 1 locked resource 1 and it wants resource 2. Thread 2 locked resource 2 and it wants resource 1. So unless thread 1 finishes its job, it won't be releasing resource 1. Thread 2 releases its job, it won't be releasing its resource 2. So what happens? They will never be able to acquire lock on the other objects, and they will never be able to release the objects on which they have already acquired locks on. Okay, so that's the another case. Okay, in real world, if we see the a small snippet on the right of the slide, uh, that actually represents another scenario where we'll be actually facing deadlock in the real world. So whatever I explained earlier is displayed over here pictorially. Okay, so thread 1 has acquired lock on file 1, and thread 2 has acquired lock on file 2. Okay, and then both threads have read the contents of their files, and then they are trying to acquire locks on the other file because they are already locked by the other thread. They cannot do that. So what happens? They will always be trying to acquire lock on something or other. Okay, so this is what happens whenever our process hangs or something like that. Many times this is one of the cause. Okay, some threads may be deadlocking on each other's resources. So what is the solution? Okay, so if you have analyzed the problem, okay, what actually has happened? Okay, the order in which the files are being locked actually solves the actually is the key here. Okay, if we acquire lock on all the files at once, whatever the thread needs, and then operate on all the files and release them, then there won't be problem at all. Okay, so okay, so like say for example, imagine instead of thread one, instead of locking the file and waiting to lock and first reading the file and then locking the file two. What if the thread one immediately locks file one and file two before thread two can get a chance to acquire lock on file two? What happens? The thread 2 will not be able to start until thread 1 has finished its job, which is also kind of what we need. Okay, so then thread 1 will be finishing job, reading and writing at once, and then it will be releasing at once. Okay, and then thread 2 can continue operating. Okay, that's how we can actually solve the problem of deadlock. Okay, so let me show you a small demonstration of how a deadlock can occur. Let's create through two thread classes. So first class, let's call it as deadlocker1, which implements or simply extends thread class. So let's say first we are acquiring lock on certain object. Okay, it can be anything. It can be a file, it can be a database connection, or it can be a class, or it cannot be this object, because two different classes, this objects will not be same, so they won't be acquiring locks on those things. So for now, let's first class, let's take deadlock dot class.
Uh, Buddha, are you speaking?
Hello.
Yeah, now I can hear you, Buddha.
Okay, I just took my headphones out and kept again.
Uh,
When did you lose me?
Synchronized deadlock dot class.
Okay. So now, so synchronized deadlock. So we are locking. We can lock anything, as I was telling. We can lock a DB connection. We can lock a file. We can lock a, say for example, file object or input stream or anything. We can lock. Okay. So just to replicate, and then once we have acquired lock on it, to replicate it is doing some operation for some time. Let's sleep for, say for example, 1 second. It's just to replicate the real world scenario. It may be doing some operation of reading whatever content is there in that file or etc. like that. Okay, then when we have acquired lock, let's acquire lock on puller dot class. Okay, and now let's try to, okay, and now let's take another class. Let's just copy paste it and reverse copy red locker 2. I'm sorry, control Z. So deadlocker 2, for these to happen, first deadlocker 2 class should acquire lock on puller class first. And next it has to apply lock on deadlock. Okay, so now let's run both the threads. Let's start both the threads. New, just to help us, let's first print some messages. Lock deadlock dot class. So now let's say trying to lock polar.class. Okay. Now let's print the same messages here also. So here our deadlocker2 class has acquired lock on polar.class. Deadlocker2 is acquiring trying to lock on deadlock.class. Okay. So uh, now let's run our program. Okay. Now run the file. Now what happened over here? Deadlocker1 has locked our deadlock.class, and then deadlocker2 has acquired lock on polar.class. It happened immediately, and then deadlocker1 is trying to lock polar class, but because it is already locked by deadlocker2, it will not be able to acquire lock. And because deadlocker2 is trying to acquire on deadlock1, which is acquired by deadlock1, sorry, deadlock.class, which is acquired by deadlocker1 class, and they will never be able to complete and execute that locked both. Okay, so this situation is called as deadlock situation. Okay, then generally how do we solve this? Okay, so what we did over here, if you carefully observe, we are sleeping for some time. Okay, so which is actually giving rise for other problem, or in fact we are performing some operation. Don't think this is just sleeping. If we remove the sleep, the deadlock will go away. Imagine this sleeping is not that simple sleep operation. Maybe this is some big operation like reading the contents of the entire file, or trying to get some download some internal file from internet, or making a rest call and getting some data, or opening some job and executing some mainframe job, or whatever. It can be anything that may take few seconds. Okay, so now instead of before acquiring this lock, we are doing that operation. Okay, so now let's say we try to acquire lock immediately. Okay, without waiting for the anything. Okay, so then what happens is, uh, there are high chances that these particular threads will run, these two statements will run immediately. Okay, it's not guaranteed, but there are high chances. Okay, so if we do this acquiring lock everything of everything that it wants at the same time, then if we do like this, then we will be able to guarantee it. We cannot guarantee. Okay, there are also chances that, okay, this may execute first, and then this will, before this can execute, the other thread may get chance to get executed. So that can automatically, that can obviously happen, but we will see how to solve that also. Okay, now so without doing performing any operation, try to acquire locks on everything that you need first. Okay, this way, uh, there are you can say that you will be able to escape that deadlocking situation. Okay, now what happened over here? Deadlocker one locked the deadlock class, and then it locked the polar class immediately. So it said lock both, and then it released them once it has done with the job, and then deadlocker 2 has come into the picture. Okay, but again, as I said, there are chances that, okay, once this lock is acquired, before this sentence statement can execute, other thread may get a chance. Okay, if we run this, say for example 10-15 times, we may run across that kind of issues. So that is one of the problematic things about the deadlock situation. Debugging is very difficult. Sometimes they will occur, sometimes they won't occur. Okay, imagine this slide. Okay, imagine this slide. In this slide, if the cars have come at least, say for example, 2 seconds apart, what will happen? One, at least one car would have already gone. Okay, if at least one car comes 2 seconds earlier, that car would have gone, and the rest of the other cars would also have gone. Okay, because if assume if this car has already gone, then this is free to go, and then this is free to go, and then this car is also free to go. Okay, so it's purely based on the timing. Okay, so our thread problem, this problem is purely based on timing. Okay, if both of them happen simultaneously, there are chances that this will happen. Okay, the other the care that you have to take is try to acquire locks on in the locks in the on the same in the same order. Okay, here we are acquiring lock first on deadlock and then on polar, and here in deadlock 2 we are acquiring on polar and then acquiring on deadlock. Okay, so imagine you acquire them in the same order. Now what happens when the thread 1 runs this statement, and before it can run, even if it switches to this deadlock 2, because this is also trying to acquire lock on same deadlock, then what happens is our program will not be, the deadlocker 2 will not be able to run sorry, continue until our deadlocker 1 is done with its job. Okay, so this is how we can actually avoid deadlock completely. Okay, so the other problem that can arise when it comes to threads is starvation. Okay, the starvation is typically a situation where one thread or is not getting any of the resources at all. Okay, the only the it's for a long period of time. That is, that situation is called as a starvation. Okay, so imagine when you are trying to download a file, your YouTube is not playing. Okay, your YouTube video is not playing. That is one such case. Okay, maybe you are using the all the bandwidth, or your YouTube will not progress. So the same way, multiple threads has to do multiple jobs, and if one thread cannot get any chance to run, what happens is that process will be slow. Okay, so overall, what happens is your threads will not be run our application will not be running efficiently, because one, at least one thread will be lagging. It's like it's like the weakest horse in a cart. Okay, horse cart. uh, so what happens, every other horse has to go slow as per the last slowest horse. Okay, so that's how it will be entirely obstructing our program's execution. And typically there is no specific reason as to sorry, there is no specific single solution as to how to solve this starvation. Okay, maybe the resource is always waiting to acquire lock on some or other objects which are being acquired by the other threads. You have to properly careful why the other threads are not giving any chance to this. Maybe a thread is acquiring a lock on file object and it's never releasing it. Okay, it's always keeping it even when it is done with its job. That file is required by the third thread. So that is in that case we have to analyze that situation and uh, solve that carefully. That's not a deadlock, but that case of where one thread is always having lock on one file and doing all its operation, that's not a deadlock, but it's like a starvation, because the other threads that may depend on that file may not be able to acquire that particular lock on that file ever. Okay, so that's okay. So those threads are called as greedy threads. So always try to see, try to release the locks whenever your work is done. Okay, that way you will be able to safely ensure that other threads also will be able to run successfully. So another thing is another reason why the starvation may come is starvation will also come when, say for example, some threads we are using, say for example, thread pools or something like that. Uh, some thread pools some threads may get the opportunity to get executed because of whatever reason. They are generally given chance in random fashion. Okay, there is no chance at all. Okay, when we are using the reentrant lock object, if we create that reentrant lock object with a true parameter in this constructor, earlier we created it without the true. Okay, so this true will ensure the fairness between switching between the locks. Okay, so when we are acquiring lock, it sees, okay, if we have already, if a certain thread has already acquired lock, it sees if there are any other threads that are not getting acquired, not acquiring the lock on the same locker object, and tries to give a chance to that other lock. sorry, other thread. Okay, that way this actually gives a little relief as to when the thread puller itself is not giving chance to run the other thread. And now there are different thread states. Okay, we are telling thread will running, thread is waiting, and thread is completed its execution, etc. So there are many thread states that are there. And if you see, when we create a new thread object, like say for example new thread, so for deadlocker one new deadlocker, d equals to new deadlocker. Okay, that is creating a thread object. So when the thread object is created, it is a new state, and then when we execute the start method, it goes into the runnable state. Okay, so when we click start method, doesn't mean it will be running. Okay, it says it is ready to run. That's what it means. Okay, and then when thread puller gives the control to the thread, then it will be running. And then once it is finished its execution, that will be going to the terminated state. Okay, imagine we from the running state, there are also chances that it may go to a waiting, like say for example while sleeping, or it is trying to acquire lock on some or other object, etc. So that way it can go to any of the locks. Okay, once it has done with its waiting, it will be again going to the running state, and then it may ultimately go to terminated, and even it may go to terminated directly from the waiting state. Okay, for whatever reasons. So these are different kinds of thread states that may occur. Now, when it comes to thread, another important topic is thread scheduling. Okay, so imagine, what did I say? There is a CPU, and CPU time will be shared across threads. So what really happens is when one thread is getting executed, other threads will be waiting, and the CPU will only be executing one thread. Okay, so this way each thread will be going back and forth between the CPU execution time. Okay, so there is a Java has a inbuilt thread scheduler that decides which thread gets executed. So when one thread is sleeping, the other threads may come in and get executed in that other place unless they are also blocked by some or other operation. Okay. So when it comes to thread scheduling problems, there are many problems. Let's say there is a main thread which is starting a child thread, and their execution may go and they will continue to execute, and they may completely finish by the time the program ends. Okay, and then let's say there is a main thread and child thread gets executed, and child thread will be finished well before the main thread is completed. Okay, so even after child thread is done, main thread will continue to execute the rest of its lines, and it will be finishing. Okay, and then there is another third case, that is, say there is main thread, and then there is a junction point, and main thread has to wait at that particular point until child threads finish its execution, and only then main thread has to continue. So this is something like, say for example, waiting on a certain point until the other thread joins you, or other thread completes its execution. Okay, so this is one of the problem. We will see how to actually solve that. And then there is another thing. Okay, there is a main thread which gets executed, and child thread at some point will go to sleep, and then our main thread should be able to interrupt the sleeping child thread. Okay, so whatever however mechanism that it may use, it should be able to interrupt the other child thread. So this is a way of communicating or waiting for other threads, knowing the status of other threads. So these two are problems like that. Okay, for that what we actually use is we use the methods join and interrupt. Okay, so every problem, like as we have spoken so far, every problem has at least one thread, that is the main thread. So the new threads, if we want to wait until the second child thread finish its execution, what we will have to use is we have to use a method called as join. Okay, if we call that method object dot join, then we will be our main program will be waiting until the other thread finishes its execution. Okay, alternatively, if we want to wake up another thread that is sleeping, what we do call is we call that particular thread and say interrupt, and then our thread will be interrupted from the sleep. Okay, so these two methods will actually help us from help us from interaction between multiple threads. Okay, so let's say we have started the thread will be printing, say for example, some numbers, and now, okay, main ends. Now let's say if we run this program, what happens is main will be ending. Main has already ended before this thread has even started, but there is no guarantee. If we run this multiple times, we may some lines of class exiting extending thread may get executed, and main ends may come a little later. Okay, here it's not happening because the computer is very fast and switching the thread even before the other thread is getting chance to run. Okay, now what if we want to wait in this position until this thread completes? Now for that, what we do is we call the join method, and join method also has other like wait only for, say for example, a couple of seconds. They also have other so if you see join long is there, join long millisecond, nanos is there. So nanos is just nanosecond, so it can wait until that particular that many seconds. So for now, let's just see this. So now what happens is the thread dot join will make sure that the main thread will be waiting until this thread is finished its execution. So now once it's finished its execution, then the main ends gets executed. So this is how we can actually uh, do its finish its operation. Now let's say our thread is performing some operation of printing I is less than, say for example, 100, I plus plus, and I. Okay. Now, irrespective of whether the child thread has finished its execution or not, our, let's say our child thread is after doing some operation, it is sleeping. Okay, and not doing some operation. Okay, and it has to wait until main thread has, after it prints, say for example, uh, for int I equals to 0, I is less than 50, I plus plus. Now after printing 50 numbers, it has to sleep until the main thread finishes its job. So for example, or it has to sleep for at least 1 second. Let's imagine that's one case. Okay, so now then it has to print another 50 numbers. Now our thread runner is printing these numbers. Okay, now what has to happen is we know that our child thread will be sleeping until it finishes its job. So now it has printed all the numbers. Now what we can do is actually we can say t dot interrupt. Now what happens is once it has printed all its numbers, then if the class is sleeping, if it is sleeping, okay, always remember, if it is sleeping, then it will be calling interrupt So calling the interrupt method. So whenever if it is sleeping, okay, there is no guarantee that it will sleep. Okay, but let's see, for example, let's assume that it does. So now if it is sleeping, then we will be calling the interrupt method. So whenever it is in sleeping, it can actually be interrupted. So that's why we are always putting the interrupted exception, or we are putting it for throws. But because this method signature is constant by means of this thread class, we should not be throwing new exceptions. So that's why we have to always surround it with try catch block in this method. So now if it is interrupted, it will be calling the getting this exception, and it will be printing the message that okay, it got interrupted. So it will be catching, it will be caught here, and then because we are not read throwing, the next statements will be continued. Let's try to run and see what happens. And now if you see, the child thread, main thread is printing, child thread is printing, and main thread has printed, say for example, 50 numbers, and child printed 30 numbers, and then child has printed 50 numbers. Okay, and then main is still continuing. And why child is not getting any chance now? Because child is sleeping. And once main has finished its execution, main has ended, and then it has interrupted the sleep of the child thread also, because we call t dot interrupt. Okay, so because it is interrupted, now it is come out of that particular try block where it is sleeping, and now it is executing the rest of the statements. Okay, so this is how we can actually make sure that that one thread interrupts the sleep of the other thread. It has to have the object reference of that thread, and then it can actually interrupt the other threads. Okay, so that's how we can actually use the join and interrupt. And then there is another thread scheduling problem. Let's say there is thread 1 which is actually printing all ones. Okay, and then there is thread 2 which is printing all twos. Okay, now we have to somehow manage that. We have to run these through two threads simultaneously and ensure that we get a alternative printing output. Okay, like one thread has to print one, and then another thread has to get chance. So far what you have seen there is no guarantee. Okay, one thread may run for more times, and then another thread may run for more times. So or it can even happen like this: if there is no delay at all, if it runs fast, one thread may finish its execution, and then other thread may finish its execution. What you want is like this. Okay, so each thread has to get equal chance. Like each thread should be executed only printing only one number, and then it has to give way for the other thread. Okay, now how do we solve this problem? Okay, to solve this problem, we can think of different solutions. One is each thread can go to print a number, and then it can go to sleep. Okay, and so if it does like that, when one thread is sleeping, other thread will be getting chance. But the problem is, how long should this particular sleep operation should be done? the this particular the thread one will not have any information about what is the operation that is being done by sleep. Here we know that this is just printing too, but in real world the problems can be much more wide and varying problems. Okay, so at that time, so each thread will not know how much time they should sleep. Okay, so this is not that efficient. We can put something like 1 second, that may be more or that may not be sufficient also. So then what we can do is we can actually do an operation like, say for example, print and then notify the other thread to continue, and then sleep. Okay, and then once you came out of then other thread will be printing because it got notified, and then once the other thread has printed, it can notify and then sleep. But because we are already using the sleep for a different purpose, what they have done is they have created a new method called as wait. Okay, so the wait will be waiting until it gets notified. Okay, so the notify method, whatever is done, will be passed to the wait method. So Using the notify and wait mechanism, we can actually do the job of informing other thread to continue. Okay, wait will be waiting on certain object, and notify will be notifying on all the objects that are waiting on that particular threads that are waiting on certain things. Okay, let's create new printers. One printer. So this is extending thread. This just prints one. Okay, that's it. Okay, now there is another class. So this will be printing two. Okay, and now if we run both of them, say for example, let's run them in here. Now new one printer dot start new two printer dot start. Now if we run this particular program, there is no guarantee that they will be printed alternatively. Okay, now if you see, all ones are printed and then all twos are printed. Okay, so because depending upon how fast our computer is, the printing will be finished by one thread, or it can even print 10 numbers and then switch. So now what if we want to print alternatively? Now what we have to first do is we actually use the locking mechanism. Okay, so for that, what we have to synchronize on same object. Synchronized on, say for let's synchronize on, say for example, uh, our threadrunner dot class. And both the threads have to be synchronized on the same object. Okay, so otherwise it won't work. Sorry. Now what we can actually do is, when a printer has when this printer thread has finished printing once, what we can do is we can notify all the objects that are waiting on whatever that has acquired lock on this particular thread runner or waiting on this particular object. Okay, once we have notified, then what we will be doing is we'll be waiting. Okay, and we have to catch an exception. And always it's better to have wait on, so for example, for a few seconds. Otherwise we may run into some problems, which I'll show you immediately. So now, because we do this, we have to do the same operation on the other thread also. Now let's run the same program. Okay, now what happens if you see, now how, what is happening, why is it happening like this, why it is printing properly? It is printing properly because, and now if you see, the program is not ending. Why? It is quite possible that the other thread has finished printing, so the first thread is still waiting on this to be released. So what happens? There are chances this will wait indefinitely. That's why it is always a good idea to actually wait only for a certain period of time. So for example, 100 milliseconds. And let's do the same thing in the other thread also. Now run the program again. And now that's it. We are done with the execution of that particular both the threads. Now what's happening? Let's clearly analyze here. Now when one printer has acquired its acquired lock, and then one when it has printed one, now it is telling all the threads that are waiting on threadrunner.class object. Okay, and then we are sleeping on the same object. Okay, and then we are trying to acquire lock on this particular threadrunner.class.wait. Okay, that means we are sleeping on trying to acquire lock on this threadrunner.class. Like it is temporarily releasing the lock on this particular object. That's what this means. Wait means is temporarily releasing the lock on this object so that other threads can acquire. So once you get notified, then these threads can actually acquire lock again. Okay, so what it does, it notifies, it tells them, and then it goes to sleep kind of thing. Okay, and then the thread 2, because it got notified, thread 2 will be trying to acquire lock on this, because the wait while the other thread is sleeping, this will be acquiring lock, and then it will be printing this, and then it will be notifying the other threads, which also involves one printer, and then it is going to sleep again. And then other thread will be coming out of this wait, and it will be continuing with this, and then it will be printing again, and then it will be notifying the other threads, and it will be sleeping. If it sleeps first and then notify, this won't be get executed, because if it is waiting means it will, the next statements will not be executed. So we always have to notify first and then wait. Okay, so this is how the notify and wait mechanism is working. Okay, so this actually there is a I want you guys to try this problem of solving. So for example, there are three threads. First thread is printing one, second thread is printing two, third thread is printing three. Now when these threads are run simultaneously, you have to print 1 2 3 1 2 3 1 2 3 1 2 3. Okay, so this is slightly more complicated problem, but I want you guys to give it a try so that you will understand the purpose of this threads notifying and waiting exactly, so that you will be able to solve. If you solve this thread scheduling problem, you most certainly will be able to solve any thread scheduling problem. Okay, so any questions, Kishore?
No, Buddha. I mean,
Okay.
this three means you did it with two, so we have to include one more. That will solve the three, right?
Yes, but that will actually, when you try, you will actually run into another problem. There are
Okay.
two threads that are already sleeping. Okay, and now which thread will be woken up?
Okay.
So to solve that problem, you have to put some more extra code in it. So that's why this problem is not that simple. So once you try to solve it, you will understand.
Okay.
Okay, so so this effectively completes your uh, core Java section of our training. Uh, so I actually have to go on a vacation, so I cannot take class on Friday or Saturday. So the next session I'll be taking on Monday.
Okay.
Okay, so we will be starting with the MySQL. As both of you are already aware of the database, it will actually be easy. We can actually go through the Hibernate section pretty quickly. So Core Java section has taken around taken 20 days for us, like 20 classes for us, which turned out to be around more than a month or so. But the so next subsequent sections won't take this long, because the reason I took Core Java so long is I want you guys to understand completely Core Java completely, so that the next topics will be easier. So we'll be moving a little faster for the next session, maybe 10 to 15 classes per max for each section. Like for Hibernate, we may maximum take 10 to 15, and we'll be for from the next section onwards, they will be more practical oriented. So I want you guys to use these 4 days and practice as much of Java as you want. Otherwise, things will become more and more complicated for you guys. Okay.
Yeah, fine.
So those sessions will be more interactive. So I may ask you to do something then and there immediately, and we try to solve the problem. So that way you will be learning more for the next Hibernate and the web sections. Okay. So that's it. Do you have any questions, Kishore?
Yeah, no,
Okay. Fine then. We shall meet on Monday again. I'll schedule another session. Okay. Thank you.
okay.
Bye.
Bye, bye.